is 2.4 and it's on compass and straight edge construction. So this is a section that will work much better doing it in class than on a video. We'll probably take a full class working together, so I'm going to do part of the lesson really here, but I'll give you a sense of what it's all about. So first of all, I'll tell you what a compass is and a straight edge. You know what a compass is. A compass is used for drawing circles and arcs, and an arc is a part of a circle. So if you don't go all the way around when you're making a circle, you've made an arc. And basically a compass, as you probably know, looks like this. Right? Here's our compass. I can open it up, and then I can draw with this thing, and I can make perfect circles. And I bet right now you're going, wow, that's awesome. That is a cool smartboard compass, right? I know, I like to show off with the smartboard. So I'll get rid of that, and you'll soon see that actually I'm really bad at using this thing. So you might be impressed now, but you'll soon be very disappointed in me. Okay, a straight edge. A straight edge is a guide for a pencil that allows you to draw straight lines. So think of that for a second. A guide for a pencil that allows you to draw straight lines? Wait a minute, Mr. Wadge, aren't you just talking about a ruler? No, it's slightly different. You know what the difference is? It's distinct from a ruler because it has no markings on it. In other words, you can't use it to measure distances. So what I'm going to be using for my straight edge is this, but this technically is not a straight edge. I mean, it is a straight edge, but it also has this ruler aspect to it. It has all the numbers. You can't use those numbers, okay? You have to pretend this is just a piece of rectangle here that can guide my pencil, right? Watch this. If I just draw here, it's kind of squiggly, right? But if I draw on this, it's straight. Isn't that cool? Whoever designed this smartboard stuff is pretty amazing. Okay, so you can't use the numbers on here. Alright, now what we're going to do are geometric constructions. So what are geometric constructions? Geometric constructions are when you draw shapes, angles, and lines, and you only use a compass, this guy here, and a straight edge, this guy here, but you can't use a protractor to measure the angles, etc. And you can't use a ruler. So remember, even though this is a ruler, I'm going to pretend this is a straight edge. Okay, I'm going to do 3 of them. We'll do more in class, but they take a little while, especially when I'm using these things. It's awkward using these things on the smartboard. So the first one I'm going to do is I'm going to construct the perpendicular bisector of a line segment. Alright, let me move these things down. I'm going to construct the perpendicular bisector of a line segment. So what does that mean? Well, first of all, there's our line segment, right? And I want to draw a line that's perpendicular to that one. So you know what that means. It has to be 90 degrees to this one. And it has to bisect this line too. Do you know what bisect means? It means cut in half. So basically I want to cut the line in half. Oh, I see how it just turned red? Cool. I want to cut the line in half, so somewhere around there. And then I want to draw a perpendicular line. So something like, whoops, I missed a little bit, but I'll just make it a little fatter. There, I'm done. I made my perpendicular bisector. Good enough, right? No. We want to do this so it's exact. It's really accurate, like perfect. Now, I won't do it perfect because I'm, again, struggling with these tools, but if you do this really carefully, you will get an absolutely perfect perpendicular bisector. So, how do we do this? You start by taking your compass and you put the point, you know how the compass works, you got the point and you got the pencil or pen. You put the point on one side, right on the end of that line segment. And then you got to open up your pen or pencil more than halfway across the line segment. Right, if halfway is around here, you got to make sure you go at least more than half. So I'll go to here, and you could draw a whole circle, but you don't have to draw a whole circle. You could just draw a couple arcs. One arc at the top, and another arc at the bottom. So something like that. Okay? Now, what I'm going to do next is I'm going to take this point. I'm not going to change how wide open this is. I'm going to keep the same width. I'm going to put the point on the other one. And I'm going to do the same thing. I'm not changing the width. All I did there was flip it around, but I didn't change the width. And now I draw the arc this way. And I failed miserably because they didn't touch. And what should have happened is that they should have touched when you did. So I have to go back here and I have to extend it. Oh, brother, so I'm talking about. It's just... Okay, so that goes well there. And then this comes up and goes there. And okay, we've done it. Okay, all I have to do now is take my ruler. Again, this is not easy to do, but I take my ruler and I make it so I'm going to draw a line that goes through these 2 points. This point here where those 2 arcs meet, and this point here where those 2 arcs meet. So I'll make a nice green line. I don't know why green, but here we go. And it should go right through them. So I'll get this out of the way. Let's see how we did. I'm probably a little tiny bit off. I could cheat, I suppose, and just move it over a tiny bit. That's not the idea, but you could do that. And basically what I've done here is I now have that original black line. I've cut it in two. So in other words, the bit over here, I'll do it in purple, the bit over here is equal to the bit over here, and I've made a 90-degree angle here. So this green line here is called the perpendicular bisector. Why? Because it's perpendicular to the black line, and it also bisects the black line. Okay, that gives you an idea of what we're trying to do here. Okay, the next thing we're going to do is we're going to try to copy a given angle. So I have an angle here. I don't know how much it is. I'm going to try to make an angle over here exactly the same size as this angle. So how do we do this? Well, we start with our straight edge, and I'll just somewhere over here make a straight line segment or a ray. So that's kind of the equivalent ray to this one. Notice it doesn't have to be like angled down like that. It doesn't matter. I'll just do mine completely horizontal. All I'm interested in is I can get another line segment or ray going up here so that the angle is exactly equal to this angle. Alright, so let's move this out of the way for a second. We're going to take our compass, put the point right on this vertex here, open it up a little ways, doesn't really matter how big, and draw an arc. Then I'm going to keep it the same width, don't close it, put it on this point, and also draw an arc. Maybe draw it a little bit bigger, make sure I don't mess up this time. Okay, next you're going to put this point here at this intersection point of the arc and the ray, and I'm going to open this up, or close it in this case, so it just touches. See, this is, I don't think I can actually get it perfect here. I'm going to do it like that, but I don't think that's actually perfect. And I'm going to draw a ray. I think that's a tiny bit off there. It should go perfectly through that intersection point. That's about the best I can do. Do the same thing over here. I put that point right down at this intersection point, draw a little arc. Where that goes through, right there, that's where we're going to draw the new ray. So it's going to go from this point here right through that point there. And it's a bit tough again to use my straight edge. As you'll see as I try to do it, it's really a drag. I mean, this would be really easy if you actually were doing this at your desk with a real straight edge and ruler, straight edge and pencil, but it's a little more awkward for me. So this is why mine's probably not going to be perfect, and you can get a better answer than me. So I draw that, and if I've done it correctly, if I've done it well, this angle here should be the same as this angle here. Okay, it might not look perfect, but it should be close. You're not supposed to use a protractor, but we could use one to kind of check it, and plus it gives me an opportunity to show my protractor to you. The new angle that I have here is about, it's hard to measure exactly, but it's about 51 degrees. And if I measure this one is, whoops, this one is approximately, that's pretty close, it's about 51 or 52. I'd say 51 and a half. So, you know, it might be half a degree off, but I think that's pretty good. So I guess what we could draw is, if I can get rid of this protractor somehow, go away please. I could draw something like that this angle here is equivalent or equal or congruent to that angle there. Okay? Alright, last one, we're going to construct a line parallel to a given line. So here's the line. If you want, we could also put it through a point. Let's say you wanted a line that's parallel to this line, and it goes through this point right here. We'll say it has to go through that point. What you do is you take the straight edge, come on down straight edge, and you just draw a line segment on an angle, any angle you want really, that goes through the point and of course through the line. So I'll just draw it right here. And there we go. Put your straight edge aside, grab your compass, bring that down here. Uh-oh. Come on down. We need you. Okay, you're going to put the point right on the intersection point there. Should we change the color? Why not? Let's make it red. So open up a little bit. I want it to be below the arc I make to be below that point. So I think this is pretty good. I'll draw an arc there. I'll keep it the same width, move it up, put the point there, and draw a similar arc. Okay, now what you're going to do is you're going to put the point right on this intersection point right here, and you're going to close this and move it so you get the pencil or the pen right on the other intersection point. So again, this is hard for, oh, it's not bad right there. Let's go for it. We'll use that. So we have that, and then we go up to the other one. Don't change the width. Go up to the other one, put the point right in the same spot there, and draw an arc. And as you can probably guess, what you're going to do is you're going to draw a line through the blue point and that intersection point right there. So let's move this up. It's also slow and awkward, isn't it? It doesn't have to be. If you were doing this yourself, it should be a little faster than this. Okay, I guess somewhere around there. Again, you're going to see it's not perfect, but I'm doing the best I can. It's a tiny bit below the point, isn't it? It doesn't go perfectly through the point. But what is the case, I think, I hope, I assume, is that this red line here is parallel to that black line there. So we could put the parallel signs on them. You know what the parallel signs are? You put some arrowheads on them. That shows that this one's parallel to that one. Okay, this gives you a sense of the sort of constructions there are. There's actually some really, really complicated constructions that you can do as well. Part of your assignment in this chapter is going to be to learn a construction on your own. I'll give you a list of the ones that you're welcome to learn, and we're also going to do a bunch together. So yeah, it's kind of fun. There's a lot of history to this, and I guess I'll talk about that in class with you, and I'll give you your compasses and your straight edges, and we'll have fun doing constructions together. All right, take care.